Assalamu alaikum wa rahmatullahi wa barakatuh. Today's topic is digital radio modulation. Digital modulation is a term regarding the process of encoding a digital information signal into the amplitude, phase, or frequency of the transmitted signal. Transmitting techniques. Digital signals cannot be transmitted in their original form, or in other words, digital signals cannot be transmitted for a long distances. Therefore, we need to use digital to analog converter to convert the digital signal into an analog signal for long distance transmission. After reaching the destination, we will use analog to digital converter to convert back the analog signal into the original form digital signal. Therefore, analog carrier signal that is suitable with the channels used is needed to transmit messages. We have three types of transmitting techniques: amplitude shift keying, frequency shift keying, and phase shift keying. For the amplitude shift keying, it's defined as digital signal is used to switch carrier amplitude accordingly. It's either low or high. Frequency shift keying changes in digital signal affects carrier frequency. Phase shift keying changes in digital signal affects carrier phase. We will go through details in this in the next slide. For the amplitude shift keying ASK, the amplitude shift keying is amplitude modulation, which is the changes of amplitude based on the input binary data. As we can see in the graph, we have 1 and zeros, which is the binary input data, and we have the frequency domain. When the input data is 1 or when it is high, the amplitude will be high as well. And when the input data in binary is 0 or low, the amplitude will also be having a lower value. The modulated signal will be 0 if the input binary is low. The modulated signal will be 1 or it's equal to the amplitude value when the input binary is 1. For the frequency shift keying is frequency modulation, which is the based on binary input data. For this frequency shift keying, we will also have an input binary data and the frequency domain. When the input data in the binary form is 1 or high, we will notice that the modulated carrier frequency will be extremely high or extremely, let's say, fast. It's high. It's having high frequency. And when it is low, or when the binary data is 0, the frequency will become slower, or let's say it's having a low frequency. As for the phase shift keying, it will, as we can notice, depend on the phase. Phase shift keying is phase modulation, which is the changes of phase of wave based on binary input data. To make it clear, we should notice that when the value changes from 0 to 1, the phase will change, and the phase is moving according to the time domain, according to the time axis. So the sine wave will continue moving as it should until it meets a change in the binary data. Then it will start moving according to the phase. Like it's move normally until we have a change in data here from 1 to 0. The phase will change and the same graph will change to the right a bit. In this case, it will be moving 180 degrees to BSK.
All right, so now we're gonna move to another topic, which is quadrature phase shift keying, which we can refer to it as QPSK. So in this modulation, or we have a lot of kind of QPSKs. We have 2-bit QPSK. We have also 4-bit. We have 3 bits. So the idea is this quadrature phase shift keying, we have some modulations here. So every degrees represented by two binaries. So in this example, in 45 degrees, we can represent it as 00. 155, we can represent it as 01. 225 degrees, we can represent it as 10, and 315 degrees, we can represent it as 11. So this signal carry twice as much information as ordinary PSK, using also the same bandwidth, which increase the efficiency. Another important thing, which is important parameters, we have something that is called bitrate, and another thing is called baud rate. So in bitrate, it is the number of bits transmitted per second, and also for the baud rate, it is the number of bits per second. So that's all from our group. I hope you understand everything, and if you have any question, don't hesitate to contact me or ask me these questions. Thank you.